Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and we're doing a decision maths video for A-level maths and it's on critical path analysis, the first video on that. Okay, so what I'd like us to talk about in this video is the following. I'd like a little introduction to what critical path analysis is all about, the big picture, just briefly, and then I'd like to introduce you to something called a precedence table so that you could represent a project via a precedence table and understand what a precedence table is actually saying. So what's the big idea all about? What's critical path analysis all about? Well, it's any project you have where you've got numerous activities that need to be completed for your output. Let's have an example here. You've got a factory and you've got workers and you've got a time frame to complete a project. So say you're completing the making of a car in this factory. Now your workers are skilled at different things. Maybe one worker is, let's say, skilled at making wheels. Maybe this worker here makes wheels. Whereas this worker here welds the body of the car together. Now, what you're trying to do is you're trying to make this car in the quickest possible time. So the first objective is to make in the quickest possible time. You're trying to complete the project in an order whereby, for example, the welder of the car can't do that job until all the people that have made their various components that need welding have done their job. So the order of production is considered. And lastly, what you want is you don't want workers sitting around with nothing to do. You want the workers to be active for as much of the time as possible. So what you're trying to do is you're trying to make this car in the quickest possible time with the workers you have and the time frame you have, such that the workers are working on different parts of the project at the same time, working in it in the order that needs to be done for it to be completed in the right order, and so that none of the workers are sitting around inactive for long periods of time. So that's what this topic's all about. Now, in order to get going with this topic, the first thing we're going to talk about is precedence tables. And take a look at this example here. Now, what a precedence table is a table that lists out the activities that need to be completed and shows you something about the order in which they must be completed. Currently, we've got a big long paragraph of things to be completed. Let's try and pick out the various activities for the project. The project in general is making a sofa. Okay, so this is the project in general, making a sofa, and it involves the following activities. The construction of a wooden frame, so that is one activity, which is fitted with springs. So you've got to fit the wooden frame with springs. That's another activity. The frame is then covered with padding material. So that's another activity. Cushions are cut out of the same material. That's another activity, which then must be stitched and filled. So the cushions must be stitched and filled. That's another activity. The assembly of the sofa is completed by attaching the cushions. So you attach the cushions, the assembly of the sofa is completed by attaching the cushions, that's another activity. Then it needs to be inspected and then it needs to be wrapped in protective covering. So iMake are having the following number of activities. We construct a wooden frame, there's one activity. We fit it with springs, that's two activities. The frame is covered with padding material, that's three activities. Cushions are cut out, which is four activities. These must be stitched and filled, which is 5 activities. The assembly of the sofa is complete by attaching the cushions, so that's 6 activities. We then need to inspect it, which is 7, and we need to wrap it in casing, which is 8. Okay, so from that paragraph I've picked out the activities, and here they are listed here. 1, 2, 3, 4, 5, 6, 7, 8. I've actually labelled them A to G rather than 1 to 8. I've labelled them A to H just because I think at this stage it's important to not say what order they're going in. So these are the activities. Now what a precedence table actually does, which we're going to draw over here, is that it tries to put them in some sort of order. What needs to happen before something else. So what we do for a precedence table, we draw a column like this, and we label the column the activity. So we have the activity here, and we have depends on here. So our activities are A to H, so we have A, B, C, D, E, F, G and H. And to build the wooden frame. Now, building the wooden frame, you don't require anything in this list of 8 things to have happened first. So A depends on nothing having happened before here. A can just start straight away. You cut out the materials for the cushions, which I've put as B. The cutout of the materials from the cushions don't require anything to have happened first. So again, this is nothing. Now C, to stitch and fill the cushions, you clearly have to have cut the material for the cushions out first. So C depends on B having happened. So we would show that in this picture. Now D was attached the springs to the wooden frame. Now obviously you've got to have constructed the wooden frame before you attach springs to it. So D depends on A having happened. So activity D, we write depends on A having happened. Now activity E, we have to cover the frame. So the frame is covered after the frame's been built and been fitted with springs. So what we could do is E could depend on the frame being built and it being attached with springs. Now, don't actually write that down. The reason is, in a precedence table, we wouldn't put A in there, we'd just put D. The reason we do this is because D already depends on A having happened. So the very fact that we're saying E depends on D having happened, that by implication shows that it depends on A as well. So in a precedence table, we only show immediate dependence, not implied dependence. So E depends on D having happened. Given that D depends on A, clearly E has to happen after A, but we don't need to show it in the table. It's shown by the way we've laid out the table. Now F, we need to complete the assembly. Now looking up here, complete the assembly, that happens by attaching the cushions. So clearly what we must have done is we must have finished C, which is the stitching and filling of the cushions, but we must also have finished covering the frame, which is E. So I'm going to say it depends on C and E. G, to inspect this, well, for this to be inspected, everything up to that point has to be completed. Now, so far in our table, we've got A, something depends on A, something depends on B, something depends on C, something depends on D, something depends on E. So if I just put here F, i.e. it requires us to complete the assembly, that by implication everything else is dependent on. And lastly H, in order to complete the wrapping, it had to have been inspected, so we put G in there. Think just quickly what this shows here. This shows us all the immediate dependencies. So it says that A depends on nothing, B depends on nothing, C can only happen after A has happened, D can only happen after A has happened, E can only happen after D has immediately happened, which means that A has to have happened also as well because D depends on A. F can only happen after C and E are finished, G can only happen after F is finished, and H can only happen after G is finished. Okay, let's have a go at another one. Example 2. So let's work through this one together. We've got a project, and the project is a new textbook, and it's broken down into activities A to G. So we're going to draw a precedence table for this, so we may as well start the table off straight away here. Okay, so the way it works is we have our activity up here, and we have depends on here. And we have A to G, so we have A, B, C, D, E. I'm going to just scroll down, F, G. Okay, so that's our activity. Activities A and B do not depend on any other activities. So A and B don't depend on anything, and we've done this. Both activities C and D can only be started once A is complete. So activity C depends on A having been complete, and activity D also depends on A having been complete, and we've completed that there. Activity E cannot be started until activity B has been completed. Okay, so let's do that. Activity E must depend on B, so we put B in there. And activity F cannot be started until C and E have been completed. So activity F can't start until C has been completed and E has been completed. So it depends on C and E. And lastly, activity G can only begin once all our other activities have been completed. Now, let's just think about how we would fill this out. It doesn't tell us explicitly, but we can work it out. Something already depends on A. Okay? Some activity depends on B. Some activity depends on C having happened. Some activity, namely F, depends on E having happened. Now, currently, nothing depends on D having happened. Nothing depends on F having happened. So G can only happen once F and D have happened. So we would put in here F or D and F. Now we wouldn't have to put the others in because the others are already, something depends on them. So by the fact that we're putting D and F in here, D and F shows us that everything else has been, must have been completed, okay? Okay, and just to finish off, I just want to briefly talk, you don't have to copy any of this now, I just want to show you where the next video is going. Suppose you have a precedence table, I just want to talk about what it tells you. So A and B depend on nothing having happened. So A and B are two activities that can just happen straight away at the start. C and D depend on A having happened. So after A is finished, you can get on with C and D, right? So we're dealt with that. E and F depend on B having happened. So after you've done B, you can get on with E and F. So that bit's completed. Now G and H depend on D. So after D's happened here, you can do G and H, right? So this is done. And I can happen after C and E. So after C and E have both happened, so this is where it gets confusing. C and E both have to have happened before I can do I. Now that's hard to show in a picture the way I'm doing it now, but C and E both have to have happened before I could do I. J happens after F, so after F happens I can do a J. K happens after G, I and J. So this is very confusing diagram now. G, I and J have to have happened before K can happen. Now that was me attempting to draw a picture. The next video is going to be me trying to represent this table in what's called an activity network, which will be a much clearer picture of representing what's going on here. But the key idea is just from a precedence table. It shows you, it lists all your activities, so these are all the activities you have. It shows you what activities immediately depend on another. So here, C immediately depends on A. It also shows you implied dependencies. For example here, because G immediately depends on D, since D depends on A, it implicitly, that means implied, implicitly depends on A. But we don't bother writing that in this column here, we just show immediate dependencies. And lastly, when you're filling in the last dependence at the end, trying to fill it in, what you can do is you can look at everything that's been depended on before. So A's been depended on, B's been depended on, D has been depended on, C has been depended on, D has been depended on, we said E has been depended on, F has been depended on, G has been depended on, I has been depended on, and J has been depended on. So the last one, L, activity L, it might say usually something like, everything else has to be completed. Now, the only things that haven't been depended on are H and K, so L depends on those two being completed, and by implication everything else is completed because things depended on it in the past. So that's it for this video. There you go, there's some extra work if you want to just solidify this extra work in, but tune in for the next video on activity networks.